Alright, I'm going to be recording. I'm recording. I know some of you guys were put in the position to be robot educators or coaches because your principal elected you to be, or appointed, or told you you need to do this. So you said, instead of losing my job, I'll do whatever they say. I know some of you guys were eager and excited about it. The whole purpose and point of this training is to make sure you guys feel more comfortable. So most 99% of our coaches that do this have no robot experience whatsoever. So we put together this training program to go over what I would say is the most important things you need to know. Typically in person, this is a 4-hour training, and I'm literally going to share all the same exact information but condensed in 2 hours. So I'm going to talk quick, I'm going to go fast, I'm recording the entire thing, so if you miss something, you can always go back to it. If you have to run to the restroom in between, you want to come back to it, you can check out the video, and we'll send that out when we are done. So I'm going to dive right in. I think I'm going to turn the webinar off right now. So I'll come back later, but I'm going to turn that off, and you should be able to see my screen hopefully. And I'm going to just go ahead and start advancing on my screen. So just a more formal introduction to me, who I am. My name is George Giltner. I'm the State Director of Robotics for TechPoint Foundation for Youth. I'll explain what they are. Quick background, I was on a robotics team in high school. It inspired me to go into electrical engineering at Purdue. While I was at Purdue, I inspired to become a teacher because I was doing some mentor program through College Mentor for Kids, and I saw it was a really kind of best of both worlds where I can teach students about robotics and electronics, which I loved, and I didn't realize I enjoy working with kids, and I was very passionate about mentoring students. So I got the best of both worlds. I combined the two, and I was a technology education teacher for 10 years. And during that time, I was also a robotics coach. And through that time, I realized robotics, not necessarily everything I do in the classroom, robotics really impacted, I would say, to those hard to reach students, whether those students are struggling academically or they are advanced and they need extra material and you can't always provide that for them. Robotics hits both sides of the spectrum, and I said this is one of the most impactful things I think you can do as a coach or as a teacher or as a school or as a community. So I'm now, fast forward, I'm working for TechPoint Foundation for Youth, and it's my job to start more robotics teams. It's like the best thing ever. I mean, I find money, I hand it out to you as coaches of schools, and I help train you and support you as much as I can with the help of Bree. So we are the robot team. And we have a new member, our third member. His name is Bradley Lefwich. He is a Vista, kind of like an intern. They'll be with us this year helping with some kind of day-to-day things. And so you might be getting emails from him as well. So moving past that, some of our major sponsors that I just want to highlight so that you're aware of. DWD, Indiana Workforce Development, is one of our major sponsors, and that helps basically pay for Bree and I's salary. They are covering all the operating costs for our this 6-year plan. We're in year 3 of the 6-year plan. The plan is to have elementary, middle, and high school robotics programs through our grant. We're in year 3 of it, going into elementary and middle school. In 2 years from now, we'll be doing elementary, middle, and high school. That's DWD. Guggenheim Life and Annuity, they're a life insurance company that has given us a lot of money. All of the robot parts and kits and everything you're going to go, I would say not go home with, we're going to ship it to you since this is a webinar. That would be cool if you hear a doorbell ring and your parts are there right now at the end of this webinar, but we're not that good. But anyway, the robot kits that you'll eventually get come from Guggenheim Life and Annuity. Their initiative and their goal is to reach and impact more girls into STEM, to get more girls excited about technology and engineering and computer science and math, to hopefully maybe they pursue these careers when they get older. So that's what Guggenheim Life and Annuity has done. They put a lot of money and support behind this. And then throughout this, I will talk about Project Lead the Way, RAC, and VEX, other partners that we have. Main objectives today, I've already kind of alluded to them. Oh, and by the way, this entire PowerPoint is on my website under TechPoint, if you wanted to follow along, but you'll see it on your screen. But it's TechPoint Foundation for Youth, or techpointyouth.org. And you go to Robot Resources at the very bottom of the page. There's a Google version of this entire PowerPoint, plus the recording I'm going to send out. So anyway, main objectives of this 2-hour training is I want you to feel more confident. quickly in the chat box, tell me how many of you are nervous about starting a robotics team. I should see a bunch of I am. Thank you, Emily. Carrie, thank you for being honest. Raise your hand. Tell me how many of you have never been to a robotics competition? Say, I've never been. I've never been to a robotics competition. Never. I mean, this is the norm. This is common. This is the training, and why we do this is to make sure that we do our best to, and this is hard as a webinar, I'm going to try to be as creative as I can, to show you what is robotics all about, why is it important, why we do what we do. You know what? I don't know if this is any more personal, but maybe I will turn the webinar. Are you on the chat? What does it do? Just put me in the corner?
You're up here. Like
oh, cool. All right. Maybe that's more personal. So the whole point of this is to try to get you more exposure to what you're about to walk into. I will be real with you. It's not easy. It's just like coaching a basketball or football team. You know, it's extra time, it's extra work, but I'm going to promise you the reward at the end of the school year is second to none to any sport or after school activity that you do. It is so impactful for the students. It will absolutely change students' lives, whether you're a first-year coach or a 10-year seasoned veteran coach. So anyway, giving you more confidence. And then the other objective, we have 3, is that you can do this. Most of the coaches, our first 2 years, or all of the coaches our first 2 years, were elementary coaches. We started in the first 2 years 900 new robotics teams. All of 99% of those coaches don't know anything about robotics, never done this before, and they all were successful their first year. So yes, you can do this. I don't care if you're an elementary teacher that doesn't understand how to attach a file to an email. If you know how to work with kids, you can do this. And the last thing is, we are here to help. It is Bree and I's job to make sure you're successful, make sure you feel comfortable. If you ever have a question, I want you to make sure that you can always ask us. My phone number is at the bottom of every email. I don't want 1,200 teachers in Indiana, because that's how many robotics teams we have, calling me, but I answer my phone as often as I can to answer questions. So there's actually later in this presentation that will talk about, if you need help, what do you do? I'm like the 6th or 7th, the very last thing. So I'm the last person to ask for help for, but I want you to look at those other resources before you get to me. But we're here. There are resources here to get you to help. All right, the way the evening's going to work, it's kind of broken down into Project Lead the Way. The very bottom one is very slight and short, so it's almost broken up into 4 sections, a half an hour or so each. So robotics competitions will talk for half an hour, game reveal will talk for half an hour, coaching, and robot kit. So, and the nice thing about the robot kit, even though you don't have it, we made a video that will walk you through. So when that robot kit does finally show up, gosh, we should plan it so that they get them literally at the end of the webinar. Like little Amazon drones drop them off, doorbell rings right at 6 o'clock or something. That'd be cool. We'll work on that for next time. But anyway, we have a video, so when you do get the robot kit, instead of trying to think back to my webinar, you can watch the video as you unpack it, and it's me walking you through what everything is in that kit. All right, you probably got annoyed because Bree, anytime you get an email that says robot grant, Bree's the one sending those, and you probably got annoyed that there was homework for you to do before this webinar. There's not a lot of homework assignments that we do, but I would just tell you, in order to condense this down to 2 hours, there were some things that you needed to do. I'm going to give you a few other homework assignments, and one is very simple. You can do it literally while we're talking. There's 18 or 19 of you in the room. It keeps fluctuating. So we should have 19, 18 new followers, because I guarantee at least most of you have Facebook or Twitter. So right now, go to your Facebook, check your status, make a cool post, whatever you want to do. But follow us on TPFY Robots. And the reason why I'm telling you this is we get money. This sounds crazy. We get money all the time that we need to get rid of. And we just try not to bog you down with emails all the time. So we'll just post on Facebook, hey, we have a great opportunity. Here it is. And we have a lot of dollars that go unclaimed. So follow us on Facebook, follow us on Twitter, either one. You're like, I don't have Facebook or Twitter. I don't know what to tell you. But We do try to give out money. We give out reminders. Hey, don't forget to do this, this, and this on Facebook and Twitter because it's a quicker, easier way than try to send out an email all the time. So we send an email every time we have something to do. You'd eventually start ignoring our emails. So anyway, first assignment. Second assignment. This is a few of you will fall in this category. Is some of you are saying you're not getting our emails, and most likely what's happening if it's a school email is you have a really tight filter or security system firewall that's preventing our emails to get to you. So if you're not getting our emails, then it would be the homework email that Bree would have sent to you, whether it's this week if you signed up or a week prior. I would say with 99.9% certainty, there's always that small percentage chance that Bree sent you an email and you didn't get it because your school is blocking it. What you do is take this robot grant at techpointyouth.org address, send it to your IT at your school or your school district and say, can you please make them a safe recipient? That's going to allow us to send you emails and they won't block them. I was told some IT people will even go in there and find all the old emails we sent you and release them to you. That's not always the case, but we did hear that does happen sometimes. So that's your second assignment. We only have 3. You're already down through 2 of them. You guys could even send that email out right now while I'm talking. Moving on. All right, now we're going to get into some actual work. So buckle up. I'm going to go quick. There's a lot of stuff. Ask a question in the chat at any time. Bree will answer you or write on a Post-it note, give it to me, and I'll respond in the actual webinar. So here we go. Are you guys ready? Are you still awake? No one fall asleep yet? Yes, Emily. Is the webinar being recorded? Yes, it is being recorded, Steve. All right, here we go. Steven's not awake. Get some coffee, buddy. All right, here we go. So there are 3 organizations that you'll hear all year long. And I will tell you, I'm going to try my best to tell you now. You'll probably forget later on, but just so we can remember that I did give this information to you. There is Vex, who actually makes the product, the robot parts, the plastic parts, the motors, the remote control, the brain. The robot. This is a robot right here. This is a Vex robot. Think of them as Lego. All this plastic stuff you get is Vex. They are a company that sells robot parts. That's Vex. You're going to get a robot kit and a bunch of extra parts. Then there's RAC. It's the Robotic Education Competition Foundation. They make a game every year that we'll go over, and I think it was a homework assignment, wasn't it, to watch the video? I think it was a homework assignment for you to watch the game video, and they come up with the rules. They put on competitions. When you went to go, and this is really confusing, but when you went to robot events to register your team on the homework assignment, that's REC. So they organize, they're like the NFL. They will organize the rules, the regulations of everything. So Vex sells the parts, kind of like Wilson sells the footballs and shoulder pads. NFL is the regulation. TechPoint Foundation for Youth would be like the YMCA that says football is really good for kids and we're going to get more kids involved in football. So TechPoint Foundation for Youth, we don't like football. We like fantasy football. We don't like football. We like STEM programs. And we said robotics, from my experience as a coach and as a robotics participant, robotics is impactful for students. We are going to get more robotics teams at schools. Whatever we can do to make that happen. So those are the 3 different organizations. Vex sells the parts, RSC makes the game. We hand out grants, train teachers, and support you as much as we can. So those are the 3 differences. This is me bragging, but I think this was somewhere maybe in the homework assignment. And there's a robot map that'll follow up. Indiana had, before we started, about 70 elementary robotics teams in the state of Indiana. After our grant the first year, we went from 70 to 520. After the second year, we went from 70 to 900, over 900. So we've grown very quickly. In fact, we have more elementary. We're not at middle school yet. We haven't took the lead in middle school yet, but I bet we will at the end of the year. We have more elementary robotics team than any other state in the country. It's amazing. And you're helping them, so thank you. Because of that, RAC said, we need to get someone in Indiana that represents us and helps with any questions that they might have. So Randy Decker is that person. He's a retired teacher from Warren Central. He is your point of contact anytime you have a question about registering for going back to REC, anytime I have a question about the game, registering for an event, registering a second team, registering for a competition, any of these things, that is Randy that can help you. He has a phone number and an email address right there that you guys can take down if you ever have any questions. So sometimes you'll email us a question and we don't know the answer because Randy handles that. We might just forward you on to Randy. We might also not. Maybe we're just too lazy that day and we don't want to answer your question and we'll just send it to Randy. That's not the case. I'm just kidding. All right, season calendar. This is where some questions might come up, so feel free to ask away, but let me get through the whole. This is, I would tell you, to be honest, you're at a mild disadvantage because you're being thrown right into September, and we're at the end of September. So you can see on here, I had training in the summertime for some other coaches in June and July, and I told them, get back in the swing of school in August, get back into your routine, and then start thinking about robotics. For you, you already got back into the swing of things. You're already mastering kicking butt in the classroom, and now I'm throwing you into robotics. So you need to start right now, all of these things in September. You need to create a team calendar. What that means is, and I'm going to show you eventually in this presentation, of like, you need to look for a competition in your area, figure out what that date is, and sign up for it ASAP. Preferably a date that's in December, January, or February. If it's a date in October that's a month away, you won't have time. November is if it's the end of November, you could barely get there, but December, January, February, and that's it. That competition's over in February. You need to sign up for an event right away. I'm telling you, that's like, it should be literally a homework assignment. I'm not sure why it's not. I guess I didn't want to give you too many assignments. But too many coaches wait until their robot is built and ready and they're perfect, and then they sign up for a competition. But I'm telling you, there is so many teams in Indiana that if everyone did that, and this happened our first year, is we're like, oh, sign up for an event whenever you're ready. Everyone waited till January, February, and all the events were full, and they had no more events to go to. So I'm telling you right now, look at a calendar, look at the local competition next to you, sign up for it, and then subtract how many weeks is it from there to where it is right now. And if that number is between 8 and 10 weeks, you're going to be having practices probably once a week leading up to that event. If that number is less than that, let's say it's 6 weeks from now, you might need to start practicing literally next week, and it might not be a bad idea to practice maybe once or twice a week. Most practices are once a week for an hour and a half. I'm throwing a lot of info at you. What I'm getting at is if you have about 10 weeks, that's a good, nice cushion for you to practice and be ready to build your team, build your robot, start, driving around and scoring points at your school to practice and go to a competition. If you only have 6 weeks, that doesn't give you a lot of time, and so you might have to multiply that by going to practices on Tuesdays and Thursdays, for example. An hour and a half is a good time for the little ones. Middle schools might be able to stretch out 2 hours, but you think about most of these practices are after school, and if you have elementary kids going to school all day, and then say, all right, try to pay attention for robotics for 2 more hours, at the end of the day, they're going to be wiped. So anyway, there's that. Other things you need to do, I'm trying to look at this September, form your team. We'll get into that more, but form your team. The robot kit you get is good for about 6 to 8 kids. I say that, but the average in Indiana is 12.25 students for one team. So you'll get a kit of all these parts, and I've got a photo in this presentation. You have all these parts, but you can't get, think about it, you can't get 20 kids around one robot. So the less you have, the better ratio you have. Now, if you want a second team, we have grants for a second team. If you have money at your school to buy a second or third robot kit, you can have a second or third kit. The average school has about 2, I think it's like 0.3 or 4 teams at their school. So most teams have 2 or more teams at their school. Your first year, you don't want to do more than that. We had some teachers the very first year have like 9 teams their very first year. That's insane. You don't want that many. Anyway, October, we're going to send a survey that is a pre-survey. It's part of the requirement for the grant. And we will hopefully have an advanced workshop, which It's just going to be a continuation of this training, just a little bit more things to think about, what to do and how to prepare for your competition coming up, things like that. If you have any competitions in October, November, and your team's not going, consider attending the competition or volunteering. Reaching out and say, can I volunteer? Attending or volunteering at a competition is a great way to see what to expect at the competition. December, you should be going to an event if you can in your area. January, you should be going to an event. I put second competition in January because the biggest feedback we got our very first and second year, when we said, what would you tell a new coach? They would say, go to 2 competitions. No joke. I mean, that was literally the most common theme is tell new teachers to go to 2 competitions. The first one might sound rude. You'll have no idea what you're doing. It'll be crazy and chaotic. And by the time you kind of figure out the routine, the day will be over and you'll be like, wow, that was a whirlwind of fun. It was hectic. I need to go to another one to actually do well. Like the first one's almost like a practice run for you and your kids. And then the second one's like, all right, this is my real competition. If you wait until going to one in January, you probably won't have an opportunity to sign up for one in late January or February. So give yourself some time, maybe sign up for 2. If, and it's possible, because a lot of our first year coaches made it to state, if you make it to state, the way you get to state is winning a competition, and it happens. State is at Lucas Oil Stadium. It's free to attend. There's a charge or fee to go and compete if you win a local competition. But if you get an invitation to go to state, that's the second week in March at Lucas Oil Stadium, which is awesome. And then the World Championship is at Worlds. And every year we've been handing out grants. We've had first-year teams make it to state and Worlds, which is crazy. But someone on this webinar might be able to make it to both. It's crazy. Good for you. But that's not why we do this. We'll talk about that later. All right. And then we'll be sending out a post survey in May. Any questions? Ask away. Bree can help you. All right. So before I dive into the actual game and things like that, I want to get into more philosophical, get everyone on the same page. Because I said in the beginning, some of you got thrown into this. You don't know what to expect. Really, a lot of people think that this webinar is going to be 2 hours of how this works. This is just an example of a robot. In my 4-hour training, I do 3 hours of robotic competitions training and 1 hour of actual kits. In this 2-hour training, I'm going to talk to you for 2 hours about robotics, why we do it, how it works, how to be a successful coach. You're not going to have any time on that robot. You're going to use that video when you get it, when you get the kit. So I'm just telling you up front, you do not need to understand how that robot works. You do not need to understand how to program a remote or how these buttons work. It's your student's job. You give them a toy, they're going to figure out how to work it. You give them Legos, they'll figure out how to build a house. You give them parts, XIQ parts, they'll figure out how to put them together and build something. So you don't need to know how to do all those things. So I'm just setting those expectations early on. So at the end of this training, you're like, why didn't I learn anything about the robot? You don't need to know how to use that. So I'm just throwing that out there early on. I'm trying to make this as interactive as I can. I'm not going to get to talk to you guys that often, but in the chat, answer this question. What do your students want to be when they grow up? What are the jobs right now that students want to be when they grow up? They want to be a what? Waiting for answer. An engineer, computer programmer. Oh, wow, we've got really good kids. An athlete, YouTuber, those are common. Athlete, yep. So engineer, computer programmer, that's awesome. A pro gamer, that's a funny, popular one. An actress, rock star, things like that. So it's a common answer. That's what we get from most of our students. Who do our students grow up to idolize? Throw out some answers. They want to grow up to be a YouTuber. Yep. Who? What are the names? They want to grow up and be just like, give me some actual names of people. A ninja. Mm-hmm. LeBron James. Yep, that's common. Anyone else? Actual names? When's it not scrolling now? Logan Paul. I don't even know who it is. Logan Paul? I don't even want to look it up. Trump, Bill Gates. Oh, that's great. So my point in this, and Aaron Rodgers. So let me go through some other questions. Ready? I'm going to show you 6 photos. Shout out in the chat who they are. Here we go. Not Aaron Rodgers. Peyton Manning, good. Who's this? Michael Jordan, the best basketball player of all time. Who's this dude? LeBron James, the biggest crybaby of basketball of all time. Who is this woman? The answers are not pouring in. I guarantee you someone's got to get one. Queen of Mary is a common. Yep. No. No. I'll tell you, her name is Ada Lovelace. Does anyone know who that is now that I've given you the name? Programmer, here, Bob, you got it. She is known as the first programmer the world's known. What she is a mathematician that figured out how to create what's called an algorithm for this mechanical counting machine this German engineer was creating. So she didn't actually program computers. What she was able to do is create a algorithm. You can Google that what it is, but that's kind of the foundation and backbone of coding. This isn't, I don't mean to be sexist or disrespectful, but I would say most of you, if I said, what does the first programmer look like? It was probably a white, nerdy dude with glasses, not a woman. And I think that's a really neat, interesting thing a lot of people don't know about. Let me ask the next one. Who are these two dudes? Mark Zuckerberg. I mean, it's close. I even usually give the name here and people still don't know. These are the Google guys. Hey, William, good job. These are the Google guys. The Google brothers. They invented Google. We use it every day. We use it all the time. It's a verb to us now. We don't even know who invented it. Who's the last person? This guy's a little more common. I think people are starting to figure it out. And if it wasn't for the car, most of us wouldn't know. Tell me, what has Tesla done? What are some inventions? And it, again, was not the car. DC power. AC power. AC, conspiracy theory. So he has done a lot of different fascinating things. He's an inventor of and has multiple patents. But what's really neat about him is he is actually, and this is a stretch, known for inventing the robot and how he created, again, a lot of different things, but the inductive motor, which led him to make a radio frequency, which led him to make a remote control boat. And then he documented in a journal, this is according to Wikipedia, so I'm sure it's really reliable. He documented in his journal that it would be really neat to one day make a human, remote control, human operated mechanical type of robot. So in his stretch, he has invented robotics, but he has made a lot of really neat, fascinating discoveries. And the point of this is I just showed you 6 very, I would say, not famous, because the last 3 we didn't even know who they were. I give you 6 people. The first 3 we all knew, but what have they done to help us? And then the last 3, we didn't even know who they were. And the reason why I'm going over this is because we use programming and software every single day in everything we're doing. Right now, I am talking to you. You can see me from your own classroom or home because someone figured out how to use software and hardware to make this internet work. And think of all the capabilities that we're able to do. Google probably had a lot to do with that as well. We didn't know about this. And the reason why is it's not I'll say the word sexy, it's not a sexy profession. It's not something that's really exciting to watch a programmer work. You can't look over the shoulder of someone coding and be like, wow, that's so exciting and neat, like you can with Peyton Manning throwing a touchdown over the Patriots and, you know, beating Tom Brady. Like that's so much more exciting. So what robotics does, and I'm bringing this back all around now, what robotics does is it makes engineering fun and exciting. These competitions that you go to are going to be some of the most amazing thing that your students, regardless if they're involved in sports or not, some of the most amazing things that your students will be involved in, because they're actually competing with a robot that they designed and built from their imagination from scratch. They didn't copy, they didn't have blueprints or instructions. They built this on their own, and then they're competing with other teams that have a different robot that does something different, but they have to play the same game. And it's basically taking engineering and sports, engineering, very smart and impactful, sports, very entertaining but useless, and combining them together, and it's the best of both worlds. So that's why I do robotics. That's why I think it really impacts students. I'm not saying sports is so useless that we don't need to benefit or have them in our schools. It does teach soft skills, but what the problem is, my soapbox here that I do often is you invest so much time, money, and effort into sports and athletics, but not every school has a robotics team. Every public school in Indiana has a football and basketball team, just about, and we invest hundreds and thousands of dollars and millions of dollars in it. But sometimes, and this is just me, I guess, complaining about my job sometimes it's literally hard for me to hand out hundreds and thousands of dollars of grant dollars to start robotics teams. Like, that shouldn't be a problem, but it is. So you, by starting a robotics team, is changing the culture, I think, of our education in the right direction, whether you know it or not. So thank you. Moving on. Types of robotics, types of students robotics attracts. So all of you are going to have to form a team. But the reason why I do this and I show this screen is because robotics attracts people all over the spectrum. Students that hate school, don't want to be there, they're disconnected, they're sitting in the back of the classroom, they never do any homework or ask questions, they're unengaged. Or the students that are in the front of the classroom asking questions all the time, always getting done early, always asking to help. Both of those students can benefit robotics in a large way. And I've had students on every single level of these spectrums, and I've seen them literally evolve into such a better person and student because of robotics. So when you're thinking about forming your team, I would not suggest holding a school-wide call out saying we're starting a robotics team, because the problem with that, the obstacle or struggle with doing that, I shouldn't say it's a problem, is you'll probably get 50 to 100 kids show up to want to join the robotics team because they think it sounds awesome. You can't manage 50 to 100 kids your first year. You can handle, in my opinion, about 15 kids, maybe 1 to 2 teams. So don't open it up school-wide. Maybe select students from your personal classroom. Ask teachers for recommendations of students. But why I put this spectrum out here is because I don't want you to think of the smartest kids with the straight A's to join the team, because there's students that struggle can really benefit from this. You have students that are, have IEPs. This would be a great program for them. And then going back to the whole sports analogy, there are students that will never ever be on a team. And you can just, going back to your high school days or maybe some of your college athletes, think of all the wonderful things that being on sport taught you, working with a team, overcoming problems and obstacles and challenges, learning how to lose and fail, and how do you overcome that? How do you get better so that you're prepared for the next competition? So all those things you learn in sports, a lot of these students that are on robotics are never going to be on a sport. Just say it because they're geeks, they're nerds. They don't think that they fit in. They're not athletic. So being smart and using your brain is something that can be glorified and celebrated, and this is the way to do that, robotics. So moving on to the next slide. What do engineers do? Throwing out that question. What engineers do? Design, test, build, yes. Create, build, blow stuff up. They absolutely do. They create, they build, they innovate. All right, these are all great answers. So every single one of you has the right answer, and I'm going to say this wrong. I'll just say Miss Johnson. Is it Cricket? How do you say her name? Kriquet. Never heard it. Sounds awesome. Cricket. No way. That's how you say it? That is awesome. Would you love that name? Mm-hmm. Cricket? Have you ever met anyone Cricket? Sorry, my side.
Somebody that had that nickname. But
that is awesome. All right, sorry. Cricket had it right. Cricket said solve problems. So what engineers do, they solve problems. And that's what I think is great. And I talk to my students about it is they design, they test, they build, but what it really comes down to is they solve problems. So why you can use this during your robotics season is your robot will break numerous times. In practice, it's not going to do what you want it to do. You go to competition, especially your first year, your first competition, you will get your butt kicked. You'll be in last place. I'm just setting the stage so that you're realistic with this. So I go back to my students and I say, the robot broke. I'm not going to fix it for you. Engineer a solution. Be an engineer and solve a problem. Fix it. Make it better. Make it stronger. Make it more competitive. Make it score more points. You are the team. This is your robot. Don't look to me to give you the answers. And that's the greatest thing I think about robotics is this is an opportunity for the kids to really take ownership of something. In football and basketball, you go to practice and your coach tells you what to do every single time. You don't really own the team. You're a part of a team, but you don't really own it. Robotics, you can give some ownership to these students and say, how are we going to design it today? Let them find out. What football coach is going to say to the team, hey guys, what plays do you want to play? How do you want to run the game? I mean, that doesn't happen. In robotics, you can open it up as a discussion of how you want to design it. What kind of robots do we want to be? How do we want to play this game? How do we want to take on this challenge? So anyway, hard skills, soft skills. I think that the hard skills that are obvious that happens in robotics is you've got programming, you've got electrical sensors and wires and motors, you have mechanical is putting things together, you have mentors, maybe bringing in STEM mentors, and teamwork. The kids are going to work together as a team. The soft skills that happen, just as being on any athletic team, but it's amazing how this happens in robotics, is the students will have to learn how to communicate. You've got 12 different, we'll say a team of 8 different personalities, all have an idea, but you only have one robot. So how are you going to get them to work together? That's probably going to be your biggest challenge is learning how to get the kids to work together as a team, how to collaborate, how to compromise, how to problem solve, how to think critically. And everything they're doing on a robotics team directly relates to the real world. And there's not many things you can say in athletics that does that other than those soft skills. So all these hard and soft skills that happen in robotics directly relates to the real world. And what do we do as teachers? What's the number one goal of teaching? In my opinion, is to prepare students and connect it from the classroom to a career. Whether that's going through college, whether that's going to trade school or directly into the workforce. That's what robotics does. So anyway, moving on. So this is my bragging robot map I love to show off. It's on our website, but why this can benefit and help you. In fact, this isn't even the most updated. There's even more little blue dots. All these blue dots represent, and I'll show you where it is. I'm just going to pull up my website. This is what's great about webinars is I can just show you all this. On our, here's what I was showing you on robot resources. All the way at the bottom is this PowerPoint that I'm going over right now.
You're out.
Can you mute? Whoever's not talking, I guess they're not all muted. So I'm going to go down to up here to robot map. And here's why I'm showing you this, other than to brag, because I think it's awesome. But all these, and it's going to take a minute to load here because there's a lot of information. And now we're on a webinar, and it's still blank on my screen. So here it comes. Here comes the dots. All right, I think they loaded for you. If I lived, let's say, in Kokomo, Indiana, I'm going to zoom in. And let's say my school is right here. If I click on that, here's Howard Elementary School. Right next door down the street, here's a school, Sycamore. Here's a school, that's Sycamore again. I keep clicking on the same exact one. I'll move further away. Northwestern. These blue dots are valuable resources for you and your community. I can put you in touch with, if you look on this map, with any of these with any of these teachers. And I'll tell you, I say this all the time, and I don't know why, but I do not get a lot of requests for this. So, you want to answer that question? There's one up. So, please use these teachers. All of these teachers that have been doing this for 1 year will be valuable resources for you. So please look at the robot map. Look at where the blue dots are. Those are other teams in your area. and talk with them. Make an introduction. Just say, hey, I'm new. I just want to introduce myself. If there's any advice that you can give me, let me know. Exchange phone numbers, become pen pals, drink beer together. I don't care, but I want you to reach out to these neighbors in your community that are robotics coaches. Okay, so that's why I showed the robot map and to brag that we've gone from 72 to 903, and we've already handed out 185 new grants. So it's really expanding. Did you see the question out there, Bree?
Yeah.
Okay.
I was actually just trying to remember if
Middle. Okay, I'll just answer. I can answer it right now.
Okay.
The question is: middle school participate in elementary competitions? No. There are a few called blended events, but elementary teams, and when you go on the website, Robot Events will show you, elementary teams go to elementary events, middle school go to middle school events. Some schools have them together, but they're in separate, ones in one gym, ones in the other. They happen in the same exact day. And some do blended, which is elementary and middle school competing together. This happens in very rural areas that might not have a lot of different competition opportunities. So most of you are going to say no, elementary and middle will not compete together. Yep. All right. This is what I was going to show you as far as competitions. Last year, before we started, they only had 7 competitions in Indiana. Last year, they had 62. That's a loaded question, William. Bree is going to paste what it says in the rules for what is elementary or middle. If you were awarded an elementary grant, you are an elementary team, you'll compete elementary. If you registered in your middle school team, you will compete only as a middle school team. But there is an actual rule that defines what you are, and it's based on what we awarded you. Because Bree looked it up before she awarded you if you're elementary or middle. All right. The competitions, they're all over. Once October 1st happens, all the events should be on Robot Events for the year, and I will update our map. In fact, on our robot map, it'll show all the competitions as well, and you can click on a little green link, and it'll show you the sign-up link and things like that. And if you want to be a event partner, someone that hosts a competition, you are welcome to do that. Our very first year, we had 30 new coaches host competitions. It's a lot to take on of coaching an event and then hosting a competition, but if you have a lot of parental support, parents, if you have a lot of administration support, if you have a lot of teachers helping you out, PTA or PTO, yeah, host an event. You can make money from it. You don't have to travel far because it's at your school, but expect in an average event is anywhere from 24 to 35 teams would be coming to your school, and it's a big task to do. So you can do it if you want. The nice thing is every team that goes, it's $30 to attend your event, and that money goes to you, your school, not you, goes to your school. So just doing quick math, 30 teams at $30, that's $900. That pays for your entire season and more. I mean, I'm talking extra, like you could buy pizzas and t-shirts and competitions and extra robot kits and registration, and you can go, go to state with all that money. So anyway, it's opportunity. If you want to know more about it, not Robot Grant, Randy Decker, that email, you can email him and he'll answer questions about hosting a competition. All right. So some of you in the room are elementary, some of you are middle. I don't know, just to get you more, see if you're awake. Why don't you say if you're elementary, if you're middle school, and then Bree is right now going to type up what all the things are, just so we get an idea in the room, what's in the room. Elementary, middle. Okay. So it looks like we have a variety in the room. Here's the great thing. Applied for middle but got elementary. Well, I think, hey, there's Cricket. There's probably a reason for that, and Bree probably looked at your grade levels, and she'll post what it says in the rules as far as grades. But what I'm telling you, which is great, is that what you see on the left side, elementary and middle schools can use what's called the VEX IQ kits, which are plastic robots. The easiest way is there's plastic, and then on the right side are metal robots. So it's middle school and high school and college does the metal robots. The difference is the plastic robots cost $300. The metal robots cost like $850, $900. Huge difference. I would also say middle school BRC, the metal robots, are kind of getting phased out. There's not a lot of the teams. I think there's only like 15 in the, maybe 20 in the state, where there's a couple hundred high school, and there's like 300 or 400 middle school IQ teams. So anyway, the reason why I show this is you might go to a competition and actually see metal robots. Don't worry, you're not the the little plastic robot that's going to get eaten by the metal robots. They don't compete together. They don't do the same things. They have a different game. So anyway, I just wanted you to be aware. And our goal is to provide elementary, middle, and high school competitions and teams so that a student that's in elementary makes it to the 6th grade, they have a team at their school. And when they get to high school, they have this team at their school. They have a whole pathway all the way to college if they want it. All right, now we get to the fun part. So just help me out here. Did we give you a homework assignment where you have to watch the video for the next level game? It's a YouTube video. It's in the homework assignment to see the game. And not getting, yes, no, yes, no, no, but I have not watched it. So you can watch the video while we're done. I'm not going to play it because it's really hard to play a video during the webinar, but if you want, you can go back and watch it. But there is a video that goes over the next level game. And every year there's a very quick, oh, shoot, I just clicked on it. I didn't mean to do that. So there's a YouTube video. Sorry, it's opening up a web. There's a YouTube video. It's embedded in the PowerPoint. You can watch it. But I'm going to explain to you in my version of how to play this year's game. So let me back up. Sorry, this is going to take a second for it to refresh. This slide shows the differences of the different games over the last 5 years. So last year is the one with the rings in the bottom right corner. Oh, you know what? I forgot. Oh, this is going to be fun. I forgot I can do this. That's last year's right there. And then the year before was this game. And then the year before that. And the year before that. And then this is the very first game ever. I forgot I can write on my screen. That's going to be a lot of fun and messy. So this is something that I think that I like to show just to give you an idea of what everything looks like. One common thing that you'll see, or a common theme, is the field, which is this rectangular white box with the black hashes or crisscross little squares. In fact, I've got a field piece right here. They come in little 12 by 12 segments like this. I think my webcam's still up. Little segment like this. They put them together and it makes an 8-foot by 4-foot field. That's what the robots will play on. Just 8-foot by 4-foot field. Our grant does not include this. This is, people ask, do I need to buy this? I would say, yeah. It's basically like trying to practice basketball without a hoop or football without a football. You will need to have a field to practice on. The field is $200. And you can reuse it every single year. It'll be the same field every single year. But if you look at the difference between these 5 photos, it's the inside stuff, the game parts, the pieces, that changes every year. The game parts are $100. So it's $300, get you the field and the game pieces. Next year, you reuse the field, you'll buy the pieces. And there'll be a different game, different parts, different objects. You have no idea what the game's going to be until next year. So let me show you. If you didn't watch the video, that's okay. I'm going to break it down for you. Let me show you. I got to erase the board. There we go. I'm going to fast forward, and I'm going to go to this screen right here. So there are 4 ways to play this game. The objective is to stack, and I've got one right here. I wanted to show you how big these are. These are the hubs. They're about as big as my face. They're probably the largest game piece we've ever had. You can only hold on to 1 game piece at a time. Oh, this is the game. Sorry, guys. Like, if I haven't really, it's kind of anticlimactic. I didn't explain it. This is like the most fun part of robotics ever, in my mind, is you got to figure out a way to build your robot to play this game. So this is the game piece. You need to figure out how to move these into the building zones, and then you get more points for stacking additional hubs on top of them. Bree, could you do me a favor?
Yeah.
Can you get an extra hub? they're in the corner. Oh, there might be one in here, but I think they're in the corner over there.
Yeah.
So I'm going to get another hub and show you something.
What color?
Nope, yeah, it doesn't. There might be one on Laura's desk if she didn't take them. So let me just show you. There's the hubs, and they're the building zones. So at the start of the match, your robot will contain, thank you, all of those hubs will be arranged in that configuration every single match. And then the building zones are in the corner there on the far right side. And if you notice, one of them is, I'll outline it. This one right here is a rectangle, and this one right here is a square. So the one in the rectangle, you can fit 1, 2, 3, 4 hubs that way, and the square you can do 1, 2, 3, 4 into a square pattern that way. I don't know if the yellow is showing up very clearly on there. So every single hub that you push over, you get 1 point in the building area. If you can stack a hub on top of a hub, and let's just ignore the color for now. Let's say they're both orange. If you stack a hub on top of a hub, you get 1 point for this one, and you get 2 points for this one. So right now, if you did this, and it was in that building zone, you get 3 points. Okay? So the whole objective right now is to get those hubs, the orange hubs, any of these orange hubs, and I'll just draw arrows. Push them into the zone. Push them into the zone. Every one you get in the zone, you get a point. If you figure out how to pick it up and put on top, you get 2 points for all of them that are raised up above. Okay? Now, sorry. Some questions get, can I do this? Yeah, you can do this. Can I do this? Yeah, you can do this. As long as it is above the first one, it's elevated off of the ground, you get 2 points for this top one. Okay? And it's where it lays at the end of the match. So you get a 1-minute match to do all of this. And to throw even more of a curveball, you'll have a second robot on the field, which is another team. And this is the crazy thing about robots, or robotics in general, is the other robot on the team is not your opponent. They are called your alliance partner. They're working together with you to score more points. And this is the beauty about robotics, and going back to the communication and collaboration, is your students, not the coaches, your students are going to have to talk to other teams from other schools and say, how do you want to play this round? How do you want to play this game? What do you do? What does your robot do? What does my robot do? You talk together, you have a little game plan, and then you go do it, which is so different in football, because in football, you look at the other team and you're like, I'm going to kill that kid. I'm going to smash him on the ground and hopefully he break him in half, which is such a weird mentality to have little kids think that way. But I was in football. That's what our coaches taught us to do. Robotics, we're going to teach the kids to work with other teams. Crazy thought, right? So you're going to have 2 robots on the field. You have no idea what that other robot will do. I usually make the joke and say, sometimes you'll be paired with a good robot, and sometimes you'll be the sucky robot. Your first competition, you'll always be the sucky robot. But we teach our students and our teams that we don't tease, make fun of. We're always positive as much as we can, and we all say we were all there at one time. We were all the sucky robot. It just happens. All right, let me go back to the game. So pushing the hubs in the building zones, moving on to the next thing. It doesn't like me drawing and fast forwarding. There we go. So when I said don't worry about this point value, or the color, is because there's 2 yellow ones, and some people don't actually see them. In fact, I didn't see it the first time I looked. But there's a yellow one here and a yellow one here. Just knocking those off, you get 1 point. And if you score them into those building zones, it's worth double. So these are considered a doubler, a multiplier. They're worth 2. So basically, if you get an orange one in the first level, you get 1 point. If you get a yellow one in the first level, it's worth 2. Oh, the sun's shining in. They almost look like the same color. I'm going to get crazy on math. Ask questions if I'm saying this wrong. If you did this, this would be 2 points. This would be 1 point. If you did this, this would be 1 point. But this is worth 2 because it's elevated and it's times 2. So this would be worth 4 points. So this would be a 5-point combination. This would be a 3-point oh, I'm sorry. Nope. 1, 2, 4-point combination. So more, less. And in the rules, it breaks it down even more. And I'll explain all that as well. I'll bring up the rules. So really, I've taught you 3 ways to score. Push the orange hubs into the zones. Stack, if you can, and then knock down the yellows, because you get a point just for knocking them down. And then the 4th way is the end game, which is park in the, and there's a slide for this. I'm going to get fancy with my PowerPoint. Bree liked it. The last one is this green zone right here, which is considered the parking zone. If you just literally park your robot, you get a point, like 1 point just for plopping your robot in there at the end of the match. Now there's a bar up here. It's hard to see, but there's a yellow bar at the top. This is going to be crazy. But if you can hang on that bar where your butt, wheels, or nothing are touching the ground, they're not touching the ground, you get 2 points. And then if you can elevate your robot, which is really hard for a brand new team, but if you can elevate your robot all the way past, and I've got a screen that I'll show you in the next one, past this very bottom line right here, which is the 4-point marking line, you get 4 points. So I'm going to break it all down one more time. Ask questions if you have it. I'm going to erase this whole screen so I can go over everything all at once. Pushing, I'm going to get the highlighter back out. Pushing a hub into a zone, 1 point. And you can see right here, I don't know if you can see this little screen right here, it reminds you how many points you get. 1 point for being on the first level. If you stack an orange on top of an orange, say they're both orange, like this guy is now worth 2 points because it's elevated, it's 2 points. If you knock, and I'm going to draw on the screen, knock an orange off, just like that, knock it off, you get 1 point just for knocking it off. If the yellow makes it into that building zone, you just multiply whatever it is by 2, because this is a doubler. And it says, I don't know why I haven't even pointed this out, it says 2-point value. It's 2 times the value. And then the very last way, the 4th way, is what you do at the end of the match. If you're in that parking zone, you just park your robot, you get 1. If you throw up a pulley and you can, or a claw, and you grab and you pull yourself up, you get 2 points. If you get so high, you get 4 points. Okay. All right. So it looks like Bree's asking or answering questions. Is there any questions I need to answer? We're good.
I think we're okay at the moment.
All right. Bree's kicking some butt with the questions. All right. So let me show you this view because I want to point something out. I want to show you this view because I did not realize this until I built my field. Right here, here, and here are, and I'm going to look at my webinar here. It's a plastic piece. Oh man, that sun is bad. Let's try this. It's a little plastic, I'm going to call speed bump. And the reason why they did this, those game designer jerks, let's see if I can get this in this screenshot like this. It has a lip, so if you're pushing these hubs, it does not push it past. You would have to lift it up or lift it completely up to go over it. So you can't push it past. Whereas, since I have this in my hand, I'm going to flip it around and show you. If you look at the building zone, these are in the building zone areas. I'm going to zoom in so you can see it right there. This has a little beveled edge, and when you push it, I'm just going to push it lightly with my finger. It has a little ramp there. I think you can see it. This is so funny, me trying to get this to do it. It goes right, ooh, maybe I should be a professional YouTuber because of my camera skills. I go right over, and you can push these into the building zone. So let me outline and show you where these were on the field. The 3 things I circled were the hard edge that does not roll over. And then the last one with the beveled edge, put that camera back, is in that building zone, which is right there. So when you're pushing in the building zone, you can just push it right over, push it. Now let me just look at my yellow screen. If I was to push this guy right here, this top left guy, into a building zone, you could not push it straight this way. You would have to zigzag down and around if you were just going to push it. And I hope you know what I understand what I mean. because what I circled here, that's a barrier right there. That's a barrier right there, and it's a barrier right there. So you'd have to make an S shape. Looks like I'm doing football plays right now. Okay. Now, I guess I left this out. I may have mentioned it very quickly or briefly. You can only pick up one hub at a time, but you're able to push as many hubs as you'd like. But you only pick up one off the ground at a time. So you cannot create a robot that goes through and just picks up all the hubs and dumps them in the building zone. You can only hold one, but you can push as many as you want. Something I'm going to really strongly recommend you do or have your students. In fact, I would just do it right now, like while I'm talking. Go to YouTube, type VexIQ Next Level. There's already videos of robots playing this game. It's probably the easiest way for you to figure out how this game works is just watch another team do it. Okay. Let me show hanging, but let me know if there's any specific questions about the scoring. It's that easy. I mean, it's orange hubs, yellow hubs, hanging, knocking off the bonuses. I really like how easy it is for scoring. Let me show you this. So this is an example of a 1 point. It's literally just sitting in the parking zone. All it has to be is like one wheel. You just get that thing in it. One wheel in the zone, you're good. Whole robot doesn't have to be in there. 2 points, it is off the field, but below the, I'm going to put the highlighter on this. That's the 4 point zone right there, that bottom edge. And if you get underneath this edge right here, that is worth, if you get above it, it's worth 4 points. If you're below it, it's worth 2 points. So off the field, but below the 4, that's worth 2 points. Off the field, above the 4. Oh, you want to say hi to the audience, Bradley?
Hi, audience.
Here's Bradley. He's leaving. All right. Probably didn't see him. All right. The only other thing that I'll show you, because this might help answer some questions. Are they asking questions about the game? Or did I explain it so well they don't have any?
More about
Oh, okay.
questions about alliances and getting paired with different teams and things like that. If it's random,
Okay.
and I was just saying that they get paired. It's not the same alliance all day long. You get paired with a different group, like each time you go up.
Okay. So on our website, Robot Resources has these 4 drop downs, and I'm going to tell you this is probably has the most useful links that you'll need throughout the entire year. So if you're like looking for information about something, you don't know where it is, check out a Robot Resource page. Most likely I have it right here. So under VexIQ competition links and VexIQ Next Level, that's the name of the game I just went over, here is the animation that you can watch if you didn't do it. It's also in your homework email. Or below this is the manual. So I'm going to pull up the manual just because I'm going to show you there's some graphics in here that has useful information that you'll be able to use. I'll also mention if we ever lose, we just got new internet like a week ago, so if we lose internet, don't panic. I'm going to frantically figure out how to get reconnected, and so just sign on. Like keep trying to sign back in. Hopefully I don't lose anyone though. Now I say that, we're going to lose internet like right away. I'm trying to pull up this manual. And all right, so here's an example. Does this hub count? In the answer, it tells you yes. If it's in the building zone but not touching outside, it counts. Does this count? And does it count for more points? No, this is 2, 4, 6. If I counted all these, it would be 1, 2, 3, 4. So that's 4 down here. We're going to assume these are orange. It shows black. I don't know why. But these are all 2 pointers. So that would be 1, 2, 3, 4 at the bottom. That would be 6, 8, 10, 12, 14, 16 total points for all these. You don't get more points because it's on a 3rd or 4th row. Apparently just drive around on a scooter. We live in Indianapolis. They have these new little rental scooters. They're just laying around. You just scan it with your phone and you unlock and you get to drive around. And Bradley just left on a scooter and he lives 1 block down the street. So I'm watching him scooter to his house. Google Lime scooters. You'll see what they're at if you don't know. Anyway, Here's another example. Does this count? It does, because it is being supported by these, even though it's hanging off the edge, as long as it's being supported. I don't even think that's physically possible. I've already gone over this. Does it matter if it's hanging on the side? Yeah, that works. Ask me questions. Are we good on the game? Can I move on? Have any questions about the game? Here's a great example you could do with your kiddos. Show them, throw the hubs on the field and say, how many points do you get? And they got to count them out. I mean, this is an example of it counting here. That would be 1, 2, 3, 4, 5, 6, because it's up above, 7, 8, because that's up above. Okay, so you go through a little quiz scenario. I think that's about all I need to show you in this. But anyway, this is the manual. It's 29 pages long. You do not need to know all these rules. Your students need to know all these rules. So here's an example of you cannot carry 2, but you can push a bunch while carrying 1. So that's in the video too. All right, I'm going to go back to this. I'm going to move on if there's no other questions. Either you're...
Send them the link to that.
Okay. Do the animation and the manual if you wouldn't mind, Bree. And then you might as well do the link to the robot resource page. Either you fell asleep on me, you gave up, and it's 5 o'clock in the news. I don't know. Or I just explained it so well that you don't care. I mean, all your questions have been answered. So I'm moving on. Competitions. I think I'm gonna do my best to show you how competitions work. Until you actually go to want to experience it, it's confusing. So I think we sent some videos in there to highlight videos to see the background of what a competition looks like. It's in my opinion, it's almost like homecoming for robotics. Kids paint their faces. They're screaming. They're cheering on the robot. It's hectic, crazy, awesome fun. So that is something that you'll experience. But this is kind of an overview of what a competition will look like. And let me get my little highlighter out. And I think I have a pen, but it doesn't show up very well. I'll try the pen this time. So the first thing you'll do when you walk into your competition is you're going to go and check in right here. Oh, it's pink. That shows up. And they'll ask your team number. You did the homework assignment. You got assigned a team number. That's your team number for the rest of the year. They'll tell you, all right, you need to go to your pits. Your pit number 3, let's say. So you go down here, and you're going to walk over here, and this is your pit. Pit is really just a table where it's your home base for that competition. Let me back up. Competitions are usually on Saturdays from about 8 till 3. And I already told you should want to sign up for a competition as soon as possible. So you'll get your robot together, your kiddos there, however you figure it out. It's a bus or the parents drive there, whatever. You show up to the competition, you give them your checking in, then you get to your pits. All right, I think I caught you all up. Get to your pits. You put your box there. You put your charging station there, which is be a charger and on a plug, so you can charge battery between matches. Kids put their jackets and lunches or something like that. And then you'll have to go through inspection. So look like this table right here, that was their inspection table. So you take it there and you go through inspection. I'll show you what they look for in inspection. And then before your matches start, you can go to the practice field. First come, first serve. You just practice. You don't need to bring your field. If you want to bring one of your hubs to practice in your field, or maybe a small section of the field, but you only have usually a very small little 6 foot by 6 foot area, you can't build the whole field there. Most teams, most schools don't want to have 30 fields in their gym. So they'll provide a practice field. And then I'll show you on the next screen a match list. You'll get a match list. And, sorry, I just got a text and it looked important. And you'll get a match list, and it'll tell you what matches you'll have. Most competitions, you'll get 8 matches. They're 8 one-minute matches, and they're dispersed throughout the day, starting around 9, 10 o'clock, all the way till 1 or 2 o'clock. You make it to the finals, single elimination, or you get 1 match, and then they take the best of whoever was in that finals round. So, practice, went to the pits, you get your match. Very first thing you'll do when you go to your match, you're going to go to queuing. Looks like the table over here. So your drive team, which will be 2 drivers and the robot, will walk over from the pits over to queuing. they'll say, all right, you'll be on field 1. So you'll walk over here to field 1. The kids will drive. The rest of your team will go here in the audience, sitting here. They'll watch your team compete. They'll cheer like crazy. You go back, your kids will go back to the pits and celebrate the team that just drove. And they'll say, yeah, good job. You got 3 points. Awesome. All-time high. Next time, let's see if we can get 4. Let's encourage them, to not get 40. We'll just take baby steps. Maybe next time we get 3 again, whatever. So you celebrate the success, and you get 8 of those, 8 matches throughout the day. And every time you'll probably be paired with a different team. Any questions on the layout? All right, I'm moving on. This is what a match schedule will look like. Let's say we are team, I don't know, I'll just circle one. 3, 4, ooh, I can use my highlighter to highlight. Duh. Oh, let's do this one. This is an easy one to find. 2, 2, 2, 2, 2, 2, D. So let's say that's us. When you get your match list, I would highlight your team. So we play there, we play there. And this isn't a good example because most of your matches won't be that close, but I made this just so you can see multiple matches in a day. So it looks like we're going to play at 3. We're a match 3. We're going to be match 5. We're going to be match 10. We're going to be match 17. And we're going to be match 19. So this is what I would say is you have your biggest block of time right here in this time frame between about 9 and, see, that's the time we'll disregard because it says between 9:09 and 9:15. That's, I mean, most of your matches, your big break will be like 45 minutes. So this was a condensed schedule just to fit multiple matches on there. But what I suggest you do is you highlight where your matches are, and then you look at who your opponent or who your alliance partner is. I should not have said that bad word, opponent. Your alliance partner, 98482-9A. So you want to go to the pits, look for that team, say, hey, we're matched up in the next round during match 3. My name's Chris, my name's Sally, I'm the driver for our team. What do you guys do? And talk to them about strategy. And then be like, oh, cool, what bar would you like to hang on, the left side or right side? Would you like to be positioned on the left side or right side? What do you go for, the orange or the yellow? Okay, and they have a conversation. This is such a cool part of robotics is they have to learn how to converse with other students in a polite way. You can't be a jerk about it because you want your opponent, alliance partner, to score a lot of points because your score is your two scores combined together. That is what your points will be. So if you get 5 points and they get 10 points, your score for that match is 15 points. So you don't want to be paired with someone that's bad. You don't want to talk trash to that team because you want them to do well. You want to collaborate and work together like an alliance. So that's the match schedule.
But that will happen if they might get paired with another team that isn't the greatest. And then they might get paired with a team that's wonderful.
Like Bree said.
That was something they were asking
Yeah,
about.
you will be paired with teams that suck, and most of the time you will be the team that sucks. And it's randomly generated, so I have coaches say, well, it's not fair, they're paired with a good team every time. It's like, it's random. I can't, that's just how it works. Played football on a windy day, and if it wasn't windy, I would have gotten that field goal. Like, it's just, it happens. So anyway, it's luck of the draw who you get paired with. And the other nice thing is there's 8 matches. Every 4 matches, they throw the lowest one away. So they might throw this one, they might throw that one away. Whatever your lowest match is, they'll throw that away. The computer will do that automatically. Is there any other questions out there?
Did you already talk about skills and...
Oh my gosh, my thing hasn't been scrolling down. That's why I thought no one was asking questions.
Oh.
I haven't heard anyone talk at all. No, I haven't got the skills yet, but I will. All right, moving on. So there are 3 ways to play this game. And I would suggest you do all 3, but at your competition, every single one of you will do the teamwork challenge. That is what I've described to you. It's 2 robots on the field, you and the other team, playing together, getting points, and then the points are combined together. That's the teamwork challenge. You'll get 8 matches of those. The confusing thing, and this is just weird, is there's what's called a skills challenge. And a skills challenge is your robot on the field all by itself without another partner. There's no schedule. It's first come, first serve. And this is your opportunity to prove to the world what you can do without another robot. Because as we all admit, sometimes you're with a bad robot and you don't get a lot of points. Sometimes you get it with a good robot and you make it to the finals, but you had no business making it to the finals. You just got the luck of the draw 8 times. Really lucky 8 times. So skills is basically you playing by yourself to see how many points you can get alone. And there's 2 ways to do that. One with the remote control, driving, called the driving challenge. You have a remote, you play the game just like you did the teamwork challenge, and you drive the robot. The second one is autonomous mode. And autonomous mode is programming the robot to play the game without a remote control. So autonomously, and that was one of the vocab words. And what I like about programming is it gives a different type of student to get involved in the competition. So, you're only going to have 2 drivers. Those can be 2 different drivers every single time. So you have 6 kids every 3 matches. These 2 are driving, then these 2 driving, and then these 2 driving, and you just rotate them through. You can do that if you'd like. And then you have programming. So you can have your programmers that program the robot, and they just focus on the skills challenge. You do that too. So anyway, robot skills challenge. Programming skills challenge, the way it works is you do your driving skill challenge, you get points. Your programming skills challenge, you get points. You add those 2 together, and that is your robot skills challenge. Most competitions, you get 3 chances for driving and 3 chances for programming, and they take the best of those 3. And that's your skills. Okay. All right. So someone's asking about, and I'll open this up, Steve, is these. These are not the same as a super kit. They have less parts, but as Bree's probably telling you, is they're on back order right now. Hopefully they'll be in soon. If you were completely desperate and you wanted to get these, it's fine. But it does not contain all of the same pieces. They are legal to use. They just don't include all of the same pieces as your super kit. We don't buy these for you. Like we don't buy extra kits for you. We're giving you the super kits, and you guys will get your super kits.
So it's just a waiting game right now for us too, for when the manufacturer gets those in.
No rechargeable battery plus no case. Yeah. So, question is, how quick will we get them? We literally have a fundraising event that we ordered for, and we don't even know if we're going to get them. So they say 8 weeks on the website, but they've been saying 8 weeks for a month now. So I think it's just a blanket 8 weeks. So we hope that they're here soon. And then I know if I was hearing this on your end, I would say, how in the hell am I supposed to start coaching if I don't have my robot kit? My answer to you would be, I hear you, I understand, and it sucks, and Bree and I are literally on the phone with Bex or emailing almost daily. So what I would suggest is you can have practices where you are showing them the game and the rules, and you can start talking about how would we play this game. You can start sketching out designs and ideas, and when the kits arrive, you can start building. I, as a robotics coach, for the first 2 meetings, don't let the kids touch the robot kits anyway. And I've got an example of that as a schedule anyway. So you could have at least 2 practices, which would buy you at least 2 weeks without a robot kit, in my opinion. That's not me just because they're on back order. That's, as soon as you bring the robot kits, they're not going to want to learn the game. They're not going to want to talk and sit down. They just want to play. Keep the robots out for at least 2 weeks. Talk about how to play the game, about the rules, talk about the strategy, talk about the design. Then you start building it all. So anyway, that's my suggestion. Here's an example of 2 photos of showing, you can tell the one on the left is Teamwork Challenge because there's 4 students, and there are, I don't have my thing anymore, but there's 1, 2, 3, 4. This is a team right here of 1 robot. This is a team right here of another robot. And then over here, we've got 1 robot and 2 students. This is 1 team right here. That's the Skills Challenge. Okay? Same game, same rules, same everything, except Teamwork challenge has 2 teams. Skills is 1. All right, moving on. What program is used to code it? It is called ModKit, and we have YouTube videos on our robot resource page on how to use it. Very easy drag and drop, almost like Scratch if you've used Scratch before. So here's an example of a schedule. First round, let's say we're team 1. First round, we're paired up with team 2. We got 20 points. We both get 20 points. Let's go round 2. Our second match, we're paired with team 3, different team. How many points do we get? 30. Great. Team 3 did really well with us. So our score right now would be 50 points. So in total, our first match, I'm touching the screen without the highlighter. And our very first match, we got 20 points. The next match, we got 30 for a total, that's a plus sign, a total of 50 points. That's what we have right now. That's showing you what you get with your alliance partner is what both of you get. And it's a cumulative. I'm getting tired. Score throughout the day of your 8 matches, but again, throwing 2 of them away. Sorry, I'm highlighting mode. I gotta get better at this presenting stuff. All right. Here's a competition agenda. As I said, about 8 till 3 or so is your day. 8 to 9:30 is your check-in and inspection. I'll go over an inspection with you. 10 to 10:30, they'll have a driver's meeting talking about what do the drivers need to know during the competition. And then 10:30 till noon, you've got matches. Maybe you have lunch for an hour, like an hour break. And then matches resume, and then finals. And finals is really short and sweet. And then they hand out awards, and some of the awards don't even have anything to do with the competition. It's just your ability for students to talk to judges, because during the matches, judges will walk around who are adults, and they walk around and say, tell me about your robot. Why did you do this? How did you do this? And another great opportunity for students to actually talk to adults and professionals, to communicate using correct vocabulary, not say stuff and I don't know. They talk to them about, I used a gear with a mechanical advantage to lift my arm to give us points to elevate it higher than the 4-point goal to get 4 points. Like, they communicate effectively, and they might get awards just for their ability to communicate why they did something. So that's a competition agenda. I gave you a link here to an example of the YouTube video. I put this together. We didn't have any YouTube videos, so it's a little old. But again, I've already told you can YouTube Vex IQ Next Level and see matches playing. Oh, what? I know why I put this video in here. I'm sorry. This team, this is just to give you an idea. These 2 girls are from Grassy Creek Middle School, a kind of a low-income school in Indianapolis, that they're 2nd or 3rd graders? 3rd graders.
Yeah.
3rd graders, first year on the team. This is the state championship match 2 years ago, and they won this state championship, and this is their finals match. So if you haven't watched this video, it's really cute. It's awesome. So much excitement. And this is their first year on the team, and they're 3rd graders, and they won the state championship. So for those of you who are saying, well, I've got young kids, or I've never done this before, I mean, this is their first year on the team, and they made it to state and won. That's their robot on the left. So anyway, I always feel bad for the 2 boys on the right, because I always highlight the girls, and I don't talk about the boys, but like these kids were so cute and adorable. And we actually rewrote an article about them of being why they're so awesome. It's on our website. All right, so inspection, there's a whole inspection sheet of 9 things that they check, but really it's easy. And these are things you can do at your school before you get to the competition. We'll remind you, make sure you follow the inspection sheet. So you don't want to build a robot that's illegal. You get to the match and you can't play. I should say that back. You don't want to show up to a competition and make it illegal, because they're going to make you fix it and adapt and modify your robot to fit within the rules before you can compete. And that sucks, because if you have this arm that does great, but it's illegal, now your kid's in a half hour or hour are going to have to modify it to make it legal, and it's probably not going to be what you intended it to be. So do that before. So general rules, it's a 1-minute match, 2 drivers. After 30 seconds, they hand the remote. At 30 seconds, they hand the remote over to the second driver. You watch the video, you'll see how that works. You get 1 brain, robot brain, and you can have up to 6 motors. The Vex IQ kit we're sending you comes with 4 motors. And we bought our first year, every team 6 motors, and not a single team of our 518 teams we handed out grants to used it. So you don't need any more than 4 is what I'm telling you your first year. Maybe as you get more advanced, you might need more, but not for now. There's my buddy Kevin on his bike rolling in with his doggy. All right, size rules. The size of your robot, this is the most important. I might need, well, you know what? I'll do this. I'm going to change this camera to show you. You're going to see my desk here. Let's see if I can get this. I think you can see it here. All right. So the size rules is 11 by 20 by 15. So with a tape measure or a ruler, your robot at no time can be any longer than 20 inches long. That includes if your robot arm comes out, this arm cannot be longer than 20 inches at any time during a match. Okay? This cannot be any longer. There is already designs of a robot that your students, just like Lego instructions, can step by step put together and build. So I'll show you those instructions. Okay? It cannot be any wider than 11. Here's the hard part, 15. This robot right now is about 10 inches. It cannot be any taller than 15 at the start of the match, but it can reach up tall as it wants once the match starts. So think about that hanging bar. If you have an arm that reaches up and picks it up, it just can't be in the up position when the match starts. It has to be able to be lower than 15. But once the match starts, it can go up. So those are probably the most important rules that you need to know about inspection. I'm going to move on because I just realized I only have 32 minutes left. I have a lot more to cover. All right. Turbo mode. Expectations for your first year. Go to 1 to 2 competitions. Do the teamwork challenge and skills. What I suggest you do for a second year, expand your team. If you had 1 team this year, have 2 next year. If you have 2, go 3. Go to 1 to 3 competitions, do everything, and there are 2 other things that you can do, which is called the STEM Research Project and Engineering Notebook. You can read about them later if you'd like. Just Google VexIQ STEM Research Project, you'll read about it, or Engineering Notebook, which I already gave you a video about. You don't have to do that your first year, in my opinion. Too much to think about, worry about your second year. But you can do it if you want. And then third year, think about state. Do not, as a goal, think about going to state. I know I mentioned that first year teams have made it to state and worlds. Don't do that. That is, you're setting yourself up for failure. At your practice, if the most points you can get at practice is 5, your goal at your first competition is to get 5 or less. Like if you get 4, awesome. You get 5. To do it under pressure at a competition in front of an audience, if you got what you could do at practice, you should be screaming with joy and a high-fiving. Even though there's a team out there that can get 50 and you got 5, do not care about those other teams. You cannot judge your team compared to other teams your first year. I'm just setting these expectations so that you aren't disappointed, and I think your emotions and feelings and expectations trickle down to your students. So if you're excited and celebrating about 5 points, your kids will be excited about that as well. The way the competitions work, so there's local, state, and worlds. All of you need to worry about right now is local. You can attend state, check it out, but don't have a goal of going to state your first year. Worlds is in Louisville, which is great because some of you live on the southern part of the state. But regardless, it is 2 to 3, 4-hour drive for anyone almost in the state. It's free. It's a 3-day event. The problem is IQ is on Monday, Tuesday, Wednesday. It used to be on the weekends, but it's a long conversation. It's not on weekends anymore. So anyway, if you don't make the state of worlds, you're welcome to go and check it out. It's a lot of fun. All right. Question I usually get, how do I design a robot? Well, the nice thing is you don't have to. I'm going to pull this up right now. I'm going to try to go quickly. I think I've been talking too long. I was like right on schedule, and this always happens. I was on schedule, and now I'm not. So let me pull up this website. You know where you need to go is the robot resource page. And this is embedded in the PowerPoint, but it's lower down. I'm going to go to VexIQ specific resources, and it says robot right here, Vex IQ parts, robot build instructions. This is going to take you to a website of Vex built robots. And the video the example right here that I've been showing you right here is called StretchBot, and it's right here. The robot, and you want to write this down, the robot that your kids should start building is this robot right here called Flex. I'm going to click on it and show you it. There's like a 30-page document, step-by-step on how, 36-page document, step-by-step that tells you how to build the robot. And if you can see, it has two claws. It looks complicated. Your kids can build this. It has two claws to pick up the hubs, and it has a hook on the top to hang for 2 points. It doesn't get to 4. But your kids can figure out a way to hang for 4. But this is a great starting point. And if you look on here, this is just a little bit more complicated than Legos. Okay, they use these little connector pins that snap into these beams, whereas Legos, not to get into the science of it, is it's a flat brick that has the little bumps on the top that has a male end and a female end, and the top is the male end, and it sticks into the female bottom end of the Legos. That's what you're doing here. Is you're taking these blue peg connector pins, putting them in. You can see them right here. You're putting them inside the plastic to hold things together. So they're almost like nails or bolts, but they're just plastic connectors. So that's what you'll use in order to build these things. So how do I design a robot? What to do? I say you build the Flex robot, have your kids build the FlexBot, and then engineer or innovate a way to make it better. What is its limitations? How can we make this better? I can tell you right now, you don't have a scoop in the front in order to hurdle some hubs. As you pick up one, we want to scoop some others into this. We don't have a scoop. You're going to come up with a little bulldozer like this in the front. There's one. Doesn't go for 4 points at the top. If your kids want to figure out how to do 4 on the top, modify it. So take the FlexBot. I'm telling you this, listen to this part too. Do not go to the competition with the exact FlexBot. Make your students modify it. Make it their own, that they own it, that it looks unique and different. I'm going to fast forward to the Marshmallow Challenge. You don't have time for this. I'm not sure why I didn't delete this, but if you wanted to, this is a really cool marshmallow. Just Google Marshmallow Challenge. It's a neat activity to do for your students if you had a lot of time before they start building. I want you right now, I'm waking you guys back up because we only have 27 minutes. How will you measure success in May? In the end of the year, how will you know that you were successful as a coach? Oh my gosh, everyone's asleep. They ditched us. Hey, there we go. Good question. Did we learn things? Are we still excited? I like that, Bob, a lot. How are you successful as a coach? In May, you look back on the year, you're like, you know what? I was really successful because what? Two more answers before I move on. I know there's 2 more people awake. Oh, the kids learn. Oh, now they're all pouring in. My thing wasn't moving. Kids are excited. They improved to grow. I love, yes. I want to do this again. They want to come back. They didn't hate it. Hopefully it wasn't. Pride in learning. Yes. Everything you just said will happen to all of you or individual students on your team. And I am telling you, I said in the beginning, your first year is tough. It's frustrating. You're going to feel like, what the heck did I just get myself into? But your kids will learn things that you can't always provide them in the classroom. They're going to benefit this tremendously. So why I asked this question is, it's on my next slide. Why I asked this question is my coaching ethics is I don't care about trophies. I don't care about winning. I don't want to get you to state or to worlds. That's not what this is about. I don't want you to score the most points at a competition. I honestly couldn't care less. And this is me saying, I don't care about trophies, neither should you, because you should not be doing this in the football, basketball mentality, which is win, win, win. Your goal, your first year, is to get your kids excited about robotics, figure out how this works, get into a competition and have fun. Your second, third, fourth, fifth, honestly, I think it should take about 3 years, should you start thinking about being competitive. Your first year is I don't want to scare you, is survive. Don't sink. Don't give up. Don't quit. Do this again. Okay? So that should be your first one. This should be a student-run, student-built, and adult-organized team. Do not let parents come in and tell the kids what to do. You should not be touching the robot during practices. If there's a part on the floor, your kids pick it up, not you. You tell them, pick up that floor, you dropped it. As soon as you start doing those things, they're going to rely on you. No mom or dad bots. It's like the science project. You don't want anyone to come and see that mom and dad did this. And then my boss, as a coach, always says there's no crying in robots. That's for the adults and the students. All right, here's my stress graph. I love to show this because all of us, regardless of you went through training in June or July, if this is your second or 20th year coaching, all of you will experience this stress graph, and I want to show this to you so that you understand all of this goes through the same thing. But if you look at it, your stress level is the y-axis, going the up and down. At the very end, your stress level will be where you were before you started this grant. That's a promise to you. Before you started the grant, smooth sailing, you're teaching, you're kicking butt in the classroom. Then you applied for the grant, or your principal applied for you and told you you were going to be a robotics coach. You're like, what did I just get myself into? After tonight, I know that you're not going to walk away and know everything, but hopefully you're going to say, I got this. I can do this. The build season, which is the time where you're building the robot, will be very frustrating. And then in the middle, you're going to be like, I don't have enough time. Oh my, what I get myself into? Insert 4-letter word. Some of them will be less severe and some will be very harsh and inappropriate. And then right before your first competition, I got so many calls the first 2 years saying, Mr. Gildner, I just let you know, we signed up for an event. It's Thursday. Our competition's on Saturday, and we're not going. And I'm going to say one question. I'm going to tell you or ask you, does your robot move? Yeah, but it doesn't, it only scores like 10 points, and we hope to get 30, and we didn't get it. If your robot moves, you're going. And then I'm going to hang up my phone. And then that's that. I might be a little more polite. But if your robot moves, you're going to a competition. Because all it has, you build this thing, or even just the drive base. If you just built this drive base, not even this arm, you could play this year's game. Because all you have to do is push a hub into the corner and then go park in the middle of the field, and you can get points. So everyone's going to think they don't have enough time. If I gave you 2 years to build this robot, you wouldn't have enough time. That's just the engineering mentality. Make it better, make it better, make it better. At some point, you're going to have to say, stop building. We're going to practice driving, go to the competition. And then you're going to get to your competition, you're going to say, what did I get myself into? And I've already said, it's hectic, it's crazy, it's a frantic mess. I would suggest getting help, have parents help you there. And then after your first competition, everyone, when you're driving home, whether it's on the bus or you're in the car, you get back to the classroom, you talk to your kids, they're going to say, when is the next competition? When can we go again? And that's why I said, sign up today, sign up tomorrow, sign up now for a competition to give yourself room for a second competition. And then you'll all be robot masters at the end of this. Maybe you'll be coaching the webinar for me, and I don't have to do this next year because you'll all be robot masters. So that's my stress graph. You're gonna be stressful. I know you all will be. I was a robotics coach since I graduated high school. So I've been almost coaching. I graduated in 2000. I've been a robotics coach for almost 18 years. And I am stressed out every single time, just like you will be. Okay? Here's the page where I said, here's where you can get help. The REC website. There is a VEX IQ forum, and Bree created a coach's corner on Facebook. So if you're on Facebook right now, should be an assignment if it's not, go on Facebook and search just coach's corner, right?
Yes, I think it's under community or groups on there.
Yeah, it's a private group, and what this is all Indiana VEX IQ coaches asking questions. So the forum is worldwide. Anyone can talk on the forum and ask questions, and VEX or REC will respond. Coaches Corners are just VEX IQ Coach's Corner, people asking questions. And it's just an opportunity for you, if you don't feel comfortable asking a question, like think you have a dumb question, you don't want to ask the whole world, ask the Indiana coaches and they'll respond. There's some really nice coaches on there that are very active and supportive. Our robot resource page, look on there. Get an assistant coach, whether this is another teacher or a STEM mentor, would be someone in your community or a friend that you know that knows how to build things, put things together. They don't have to be an engineer, just someone knows how to put things together. And then I already told you on the robot map, find a blue dot in your area that I can put you in touch with someone else. And then if you have robot parts, competition, or general questions, ask Randy. If you have grant or coaching questions, ask me, and I can help you. I'm going to skip through that. This is what I would say your first 7 meetings should look like. I've been told that meeting number 2, I'm wrong. It will take more time to build, and it says stretch bot, and I'm sorry, that should say flex bot. I'm going to fix that right now so I don't make that mistake again. They just built that flex bot that I told you. The very first practice, I'm not lying, I have this, no robot, don't worry about it. Talk about what are the rules and how are we going to structure the team? Who's going to be in charge of what? Next one, and if you don't have a robot, skip to the 3rd meeting. Next one, you can either build FlexBot or start talking about strategy. How are we going to play the robot? And then look at meeting 4. Again, parts maybe, but no robot. How are we going to design an arm? How are we going to design a hook to grab onto those? The FlexBot already has it, but how can we modify that? How can we make it better? Things like that. And then I've been told it takes about 2 to 3 meetings to build the FlexBot. So allow yourself, again, you only have 6 weeks, 2 to 3 meetings of that is going to be just building the FlexBot. And then I can't say this enough, you need to drive your robot. The kids need to drive the robot. And if I had 10 weeks of practice in an ideal world, that last 8 or 9 weeks, I'm not putting another part on that robot. I'm just drive until every single kid that wants to drive at that competition knows how to drive. I have to go to the bathroom so bad, but I'm going to hold it for 18 more minutes. Like kill this Nalgene bottle. I'll hold it. I'm going to rough it out. All right. And I need to finish in 18 minutes anyway. So a lot of people ask, how do I structure my team? This is my best example. You are the head coach, and get an assistant, someone to help support you throughout the year. That's going to make your day, your practice a lot easier when you can rely on someone to help you with all the questions and the technology and things like that. So, and they don't need to go through this training, but if you want my training, and I'm going to show you another resource of additional training, I've got videos upon videos that you can pass along to anyone to watch these to get help. I'm going to show you this example. This is what most coaches do by themselves. I can't say it sucks. I did this for 10 years when I was a high school coach, but it stinks when you're sick and you have to have practice and you got to fight through it. It's a long day. You want to go home. You can't ask for your coach to fill in for you. So it can happen. It's pretty common. This is if you had a really big team. How do we come up with activities for all the kids to do? And this has been discussed on the coach's corner all the time. How do you get all the kids involved? And I even spent like a 45-minute training session. I'll show you the access to the videos of those of how to get multiple kids involved. So this is probably one of your biggest jobs as a coach is how do I get all 10, 12 kids on my team involved? The smaller the size, the better. So 6 to 8 kids for one robot. It's going to be a lot easier to get more kids involved. You have 2 robots, if you have 12, 6 on this time, 6 on this robot. But here's the different jobs. You usually have one person in charge of the field. If you buy the field, it's going to take 2 to 3 meetings for you to build that field now. Someone's building it. Someone's in charge of resetting it. Someone's in charge of all the rules so they know the field. Prototyper. You're going to have kids that just want to build, have different ideas all the time. I have this idea, I have this idea. The prototyper is the one that prototypes designs so that you can play the game. Research and design, this is the YouTuber. Those people that want to be the YouTubers, they're looking on YouTube at other robots and what teams are doing. And what that can do is spark ideas. There's a fine line of learning by example or learning from examples online. versus pausing the video and building brick for brick, block for block, what you see. That's copying. But I think you can be inspired by a video and say, oh, I never thought about picking up that way. Oh, I never thought about doing that. Let's do our version of that versus, oh, I want to build that robot. Pause it, build, go to the next frame, build. That's cheating. Don't let them do that. All right, builder. Maybe you designate. Some teams do this, some don't. It's hard to do, but come up with a way where you just have people. Certain people can touch the robot, and you can rotate that position. You can rotate all these positions, but only not let all 10 kids touch the robot every single time. Just a designated few, because that robot will get destroyed quickly if everyone has their hands on it. Electrical, not a lot of people are going to do this your first year because your sensors, you can't use the sensors unless you program. Programmer, I think all of you should, as a goal, try to program your robot for a challenge. Pit team, not going to happen your first year, but that's just someone that would make a design for your table at your competitions and maybe have a charging station or storage bin, organizing bin, things like that. And then PR, I think you should have someone in charge of PR that's going to make up your design, your logo, your t-shirt design, flyers, things like that. Okay. Most common, this is what most robot teams look like. Robot build team, the programming team, and then everything else. Okay. Oh my gosh, we're almost done. So I'm just going to show this very quickly. Bree, you don't think you can tell this story, can you?
What is this?
About these kids? I'm so bad.
Oh my gosh.
I don't know if I can hold it. All right, sorry, I'm going to just talk quickly. Bree doesn't want to be put on the spot. 13 more minutes. I really got to go to the bathroom. Sorry, guys. This is so unprofessional of me. I'm an adult. I can do this. All right. So these are 3 kids I met 3 years ago now at the World Championship, and they're from Boston, and they're second graders. Never been on a robotics team before. And my job as a judge was to go to every single team and talk to them and ask a few questions. Tell me about your robot. What does it do? Why'd you do this? Talked to 140 teams. And by far, this team impressed me the most because they could very effectively communicate to me in detail, almost as if they were an engineer at Purdue University, which is obviously the best university in the country. They were telling me about crown gears, 90-degree angles, converting energy from the output of a motor to 90 degrees for one of their lift arms. Talk to me about a rack and pinion gear and how you can translate rotational energy into linear energy. And I'm like, how did you figure this all out? They have cue cards. They practice this. No, I was trying to stump them. They couldn't. I'm like, well, Dad's an engineer. Nope, he's an accountant. He goes, these kids literally are just consumed by YouTube videos about robotics. They're reading all on the XIQ forums. They're just picking up stuff about robotics and hanging out with other teams, robotics teams, and they just nerd out about this stuff. And I'm going, this is absolutely amazing. Here's the next slide. This is their robot. Out of 140 teams, this team was in last place, and they had the worst designed robot. Same group of kids. But I had the opportunity to have about 10 different awards to choose from. I gave them at the World Championship the Judged Award. And the reason why I gave them the Judged Award, let's back up. At the award ceremony, when their name was called, when it was called up, there's literally people in the audience going, that seems, and I know in their mind they're thinking, that team sucks. They were like last place. How in the world did they get a Judged Award? And as the judge that gave that award out, I'm telling you, the reason why I gave it to them is because this is what robotics is all about. I don't care how many points they scored. I don't care that their designed robot was awful. I know those 3 kids designed that robot, even though it sucked and it could only pick up 3 balls, and the most high-scoring robot could pick up all 60 balls. This could pick up 3. The highest scorer could pick up 60. Like, that's ridiculous. The highest-scoring robot could pick up every single ball in this game. They could barely pick up 3. But I gave them a World Championship award because they can tell me how they built it, why they built it. They can tell me vocabulary terms as a second grader that some engineers cannot even talk like. So I don't expect you to know physics, science, mechanical engineering, thermodynamics, electrical engineering, computer science, programming. I don't expect you to know these things, but I do expect you to try to provide these opportunities to the students. Robotics is that first step. And in time, things will grow and it will become better. This is their first year, and their dad was not really even that involved. He said that the two kids on the left were brother and sister, and the kid on the right was the next door neighbor, and they just worked in the basement. And dad didn't even help them. So this is one of those, if they can do it, you can do it type of moments. And I'm telling you why we do robotics, and this is wonderful proof. And then I showed this video to you as a homework assignment. This is one of the teams that can pick up every single ball and score every single ball. And I'm not impressed with it. It's a great robot, but I know that for a fact that they didn't design and build that. Their parents stole it, or they saw a YouTube video of some other team did, and they stole it. Because when I walked down that aisle of 140 teams, there were over 40 teams that had the exact same designed robot. It's garbage. Who cares? That's stupid. All they care about is scoring and winning and getting points. So just think why we do things. One of my simple tips is keep things simple when you're building. My last tip before I only have 8 minutes, and I think we're actually back on track, is driving your robot versus designing your robot. I think they're different but equally as important. So give yourself time at the end to drive your robot. Don't think that you have to come up with this crazy design that does everything. Okay. All right, all of you should have registered, and if you haven't, that's one of the most important things you need to do. Is register. Bree will get after you if you haven't registered or done your homework assignments. You need to make sure you register your team. In the mail, and it will go to your school. You're going to get either 2, 3, or 4 boxes. It'll be a super kit. This is going to have the brain, the remote, battery, all of the electronics. This is a $330 kit, so if you were going to buy a second one, this is what I would suggest you get. This is everything and anything you need for your robotics team. Because Guggenheim Life and Annuity is so awesome, and because we had some extra money, and I was saying, what would I like if I was a robotics coach, would be extra parts to get more kids involved. We bought you a foundation kit. This is $100. It contains, if you look between the two pictures, it contains almost every single part that's in the super kit, plus more, but no electronics. So you'll get that. This is the top tray. Here's an organizational, just a quick tip. If you want, print this off my PowerPoint and put it on your box so your kids know where stuff goes, and tell them they can't leave until it looks like that. That's how you keep stuff organized. I like being organized, and that's the way I do it. Since you don't have your kits in front of you, I'm not going to walk through this because it's another half an hour to an hour. I made a YouTube video that walks you through every single thing that's going to be in your kit when you get it. So this is the YouTube, and I think someone pointed out that the link's in here. I'm telling you right now, Bree, would you mind throwing that in the PowerPoint?
Which one?
The me walking through this all. It's on the robot resource page. You can just click on that and put it. I don't know if they can click on that link right now. It's not on my website. It's not in the PowerPoint on the website, but it is in the robot resource page in the top links under robot kits. It just says XIQ Super Kits walkthrough. That video is in there. So when you get your super kit, go through this video and I'll tell you what everything is in your kit. Or you can just read the manual. Anyway. So here's all the things that you're going to get. I'm not going to go through it because it's in that video and we only have 6 more minutes. And I like to start on time and end on time. And have to go to the bathroom. We have a YouTube page that has everything. It's not Tech Point Foundation for You. It's my personal George Giltner. If you YouTube George Giltner, there's a channel on there that has all of our professional developments where this recording will be. We have other training videos to learn ModKit and things like that. So there's YouTube resources. I already showed you the building instructions. There'll be 2 manuals inside your kit, a green one and an orange one. The green one is for Clawbot. You don't want to use that because you're going to build FlexBot. The orange one is a manual for the brain and all your electronics. The orange one's really valuable. And I put on this slide, these are important pages on the orange one. This is a homework assignment I give to people in the summertime, but I don't think you're going to have time because you need to dive into robotics. But I usually encourage the teachers, if they have time, to build a robot themselves just so they can see how it works. All right. For those of you that are elementary teachers, you're going to get a Project Lead the Way activity. If you're middle school, you're not going to get this. So if you're elementary, there is an added part to the grant that we ask that you try these classroom activities. It's either a 1 to 6 hour activity. If you're already a Project Lead the Way teacher, you're already doing this, so you don't need to worry about it. But if you're not, you're elementary, you're not a Project Lead the Way teacher, there's a step-by-step tutorial on an activity that you can do where you can actually use the VexIQ parts from the grant in the classroom. And it actually aligns with the new science standards using the lever, the simple machines with the lever, inclined plane, and pulley. And there's a little fun activity where there's a tiger that fell down in a ditch at the zoo, and you've got to rescue him using some sort of engineering skills, simple machines. And they got to use the Vex parts, and it accommodates using the Foundation Kit and Super Kit, and accommodates 24 students. So you can do that activity. All right, these are the last things. This is literally the last things I have. So there are 10 requirements for the grant. And I'm going to go through all 10, and then I'm going to say goodbye.
Well, you can go, and I'll stay on for some questions.
Perfect. So you've already done 30% of it. 1, you need to be an elementary or middle school teacher. Done. You already did it. 2, you don't already have a VexIQ team. Done. If you did, don't tell us, because we'll still give you the grant because we already awarded it to you. 3, assemble a team of at least 3 students. There's no way that you'll be able to get a team smaller than that. You're going to have a hard time getting it down. So 4, attend a 4 to 8 hour training. I know tonight was 2, but you had a homework assignment and you have more videos you'll probably watch after this. So we're going to give you a certificate for CRUs for 8 hours of training. So to continue your teacher, so you'll be a teacher forever. And if you're in elementary, you'll have to do the Project Lead the Way activity. If you're middle school, you get out of that one. 6 is applicant will attend 1 competition. I want you all to go to 1. You have to go to 1 competition. Like, it's a must. That's what this is all about. 7, if you print any materials, we want to have our logo, Department of Education, DOE is a new sponsor, DWD, and Guggenheim Life Annuity. We'll send all that information out to you, but we need to, if you print shirts, you print flyers, we want the major donors of this program to be recognized. And anyone that gives your team money to support it should also be recognized with their logos. That's just a nice thing to do. Number 8, agrees to lead a team for at least 2 years. I don't want to do this one and done type of thing. If you don't want to do this next year, call me, let's talk through it. Maybe I can convince you otherwise. If not, I want you to find another teacher to replace you. So please think of this as a 2+ year haul. Really, I hope you find the benefit that I have found and many teachers have found for your students. It'll be hard to walk away from. And then the last one, we're going to send you a pre-test and a post-test. The pre-test is going to measure where your students are. Do they know what engineering is? Do they know what robotics is? And then at the end of the year, we ask them the same questions, and we hope, we don't care because there's no names associated, we hope that by the end of the year, it's a little higher than what it was at the beginning of the year. So did we measure that there was an impact? So I'm at 5:59. That is all I have. Was able to squeeze that in. Here's what's going to happen. If you still have questions, Bree's going to sit here for the next 2 to 5 minutes to help answer them. I'm going to run to the restroom, and I will come back and answer any more questions. So thank you all so much. I appreciate you guys being wonderful educators and teachers. I will try my hardest to get you your kits as soon as possible. But you guys rock. Thank you so much. I look forward to seeing you guys at a competition if I can be there. And I look forward to helping answer any questions. So thank you guys. Have a good night. I'll record this and send out the video to you guys probably next week. Bree's going to stay on for a little bit. I'll be back. Bye. Say bye, Bree. I'm going to turn the webcam off. I'll come back on and answer questions. Thanks, Steve. Mic's on.
I'm still here, guys, if anybody has any questions. Just a reminder again, we recorded this, we'll send it out. We have the robot resources page that we shared the link with you, and then you guys can always get a hold of us through the robot grant at techpointyouth.org. email as well. So, how does assistant receive CRU? Have them email us at robotgrant@techpointyouth.org and we can email them. No problem.
Oh, yeah.
Thank you guys. William, we will have a kit for you tomorrow. Next is have the add-on kits in stock. Will those get sent out after we register?
I'll pull up, William, I'll pull up the game, Matt. Marcella, robotgrant@techpointyouth.org. Yep, that's our email address.
Yep.
But yeah, I should have done that during the training. I didn't. I'll show you guys if you want to see. Looks like 13 of you are still on. If you go to Bex, just Google Bex IQ, and you'll go to Shop All Products, and down here, I guess I should go to the main page, and I can just do it from here. Here's the front page. I'm going to go down to Competition Products. And right here is the kit. That's the hubs, the hanging device, and those little barriers I showed you. And then, like I said, it's $100. And then this is so stupid, but I'll show you. You're going to scroll down, and this is just a selling ploy, but teachers get so excited when they see the field is only $4.99, but it is starting at $4.99. So when I click on View Details, it's just that you can buy the squares individually. So like that, what I showed you, is $4.99. So if you broke one and you wanted to replace it, that's $4.99. So going back, I'm going to scroll down. A half a field, right there it says half, is $9.99. The full field is what you want. That is $199, $200. So let me just show you. That's a full field. That's $200. That's a half field. That's $100. Two halves make a full. You wouldn't want a half field.
Is there a YouTube hack for the field?
Is there a YouTube hack for the field? No, I would. No, I don't. Never seen one before. But I would tell you this field. Let me grab another one. I'm sorry. I'm not going to bend down and get that. I'm sorry. I'll put the webcam back on. This field has these little. It's like a puzzle, and it just snaps together. And Bree, I think, can make a field in less than 5 minutes.
Yep.
She said yes. Now,
not while pregnant, but
I don't know if you noticed, Bree is pregnant, due next month. She said, well, not pregnant. But the actual game field, and I don't know if you were talking about that. This, and I'll open it up. Nope, I didn't click on that. Why'd you open? This, there's a manual that'll come with in order to build these different parts. So making this, and there are no YouTube videos on that, but that's something I would give to your kids. You can click on Docs here, and it shows the manual for it. Any other questions I can help with? I like YouTube hack. That was funny. Excuse me. Any other questions? We're going to sign off here. If you're typing, hit enter. All right. See you guys later.
bye guys.
Bye. Good night. Safe travels. All right, signing off. Boop, boop.